So this video, guys, is pretty much a continuation from the last video where we considered the data sheets on a fuse, and it's kind of a lot of mathematics, and it's probably no for everybody. But in this particular segment, kind of a part two to the initial video, let's see how this actually correlates with a real world scenario. So we'll get back to this. Let's go to the garage. Right, so we'll compare the data sheet after the fact, but what we have here is a Bussmann fuse, Bussmann data sheet. We have a 10 amp fuse with a 12 volt power supply-ish, yeah? One with a very high current capacity, I might add. One that's going to far exceed the rating on this fuse. That is a 100 watt resistor, half an ohm. So we have 12 volts, half an ohm. We're going to generate about 24 amps of current. Enough current to exceed this fuse. That's the whole point. But how long will this fuse actually carry the current for? We'll consider that data sheet after the fact. So let's hook this up. We're going to exceed the wattage rating. We're going to generate about 288 watts with those numbers. But it'll only be for very short time frame, so I'm hoping nothing catastrophic happens here. Ambient temperature in the garage is about 6 degrees, guys. There's a temperature there. So the top one is ambient temperature, and that's the resistor temperature. It's got a wee bit of temperature in it. It's a wee bit above ambient because I had to check that I had my current clamp hooked up in the correct orientation. Okay, so I'll just count down. 3, 2, 1. Contact, and it's popped. Looking closely at how the fuse is actually failed, guys, can actually speak to the type of failure you're dealing with. Is it a marginal overload, or is it a dead short? Perhaps that's a video for another day. We all knew it was going to pop. That's fine. The issue was how long was it going to take to pop, and you can see the temperature still going up on the resistor there. It didn't move much because if we look at the scope trace there, we got about 20 amps of current, keeping in mind that 1 volt is just under 20 amps, I guess. Well, what is the max? 19 amps of current, I guess it was. And you can see the battery, when it was under that draw, dropped a wee bit. Again, to be expected. Perhaps the resistance on the resistor dropped a wee bit as it heated up a wee touch. I'm not sure, but that's neither here nor there. That's all academic. The important part to note here is the actual time frame. Let me see here. I'm gonna put some cursors in here. I can indeed. Cursor 1. Two. Let's get this right. I'm a wee bit of a newbie with the modus here, guys, so bear with me. That's about right. So cursors 1 and 2. What does the data actually say? Our delta T is 763 milliseconds. Right. Let's get inside where it's a wee bit warmer, and we can take this data sheet into consideration, see if it makes some sense.
Lots of boring math later.
Okay, Bussmann fuse, ATC, the type we had. 10 amp, of course, is a red fuse highlighted by the highlighted line. So again, same scenario from the previous video. Of course, we have a logarithmic scale on both the X and Y axis. So we're starting at 1 amp to 100 amps in this case. Again, a logarithmic graphic. And the same with time. Also a notation in a logarithm. You can see from here to here is 1 second. From here to here is an additional 9 seconds. So logarithmic scale. So we were carrying 10 amps. We had the 10 amp fuse, and we were carrying in and around 20 amps, let's say, to make the math simple. You guys saw it for the graphic yourself. I mean, there's the graphic. You can see it's not quite 20 amps. It's tapering off, but let's say it's 20 amps ish in and around here. And if we follow the line up to where it intersects our line, it looks like we should have that for about I mean, is it me, or is this just like almost bang on? Somewhere between 0.7 and 0.8 seconds is. I couldn't fake this if it tried. 763 milliseconds, and you can see on the chart there where it actually intersects. Right there. Unbelievable. Not just for geeks, not just for engineers, egghead engineers. You can use it in a practical manner. Unbelievable. Awesome. I hope you guys got something out of that. I know I did. Cheers, boys.